messy-malloc, can you take advantage of misused malloc calls to leak through the service and get the flag? Connect at port 12286. Hints, if only the program used calloc to zero out the memory. We've got the source. All right, so let's take a look at that. Okay. So we have this structure that's going to get interesting. I'm sure it has a username, 16 characters of access code files, print the flag method. So the print the flag method will check, I guess looks like this global variable u, and it'll check the access code, the 16 bytes, to see if they match these. And if they do, it will print the flag. Otherwise, it's going to print out whatever your access code is. Okay. We can log in, we can print the flag, we can log out, we can exit the program. We get the username. Login is going to ask for the length of the username, malloc it, and put it in that username field of the structure. And then it lets you enter the username. Log out will free the user and the username. Okay, we just have a simple menu down here. This anonymous user, that doesn't look too useful. Okay, because the anonymous user has a zeroed out access code and a username of null. All right, well, the interesting thing about malloc is it tries to reuse memory. So we have this free of the username, and then if we can get the next malloc, which would happen here in login, to reuse that, then we should be good to go. All right. So we just want to malloc something that's the same size as this. So this is going to have 8 bytes. This looks like a 64-bit executable. I'm guessing that because of those long numbers. So 8 bytes plus 16 plus 8, so that's 32 bytes. So I really want 32 bytes there. Okay. And all right, so let's try to write, I'm going to try to write a program using pwn tools. And from pwn import star. I'm going to connect to localhost on port 12286. 12286. And then we'll say peace and line after. Let's see. So I guess we should actually just be able to figure this out from the source code, right? So it looks like it's going to, in its menu, print out this caret or greater than space. So after greater than space, we want to log in. All right, and then when we do a login, it's going to ask us for the length of our username. Okay. And so we'll send after username. We'll say 31 because it's going to add 1 to it. And then it's going to ask for a username again. And now we need to send some data. And so that data, if we look at the structure, it has an 8-byte pointer for the username, so we can just make that garbage. So it's going to overwrite it. And then we need that access code. That access code to match. All right, so 5.2, 4F, 4F, 5.4, 5F. Remember, it's a little ending in order. 4.1, 4.3, 4.3. And I have all my X's. All right, so those are those 8 bytes. And then over here, we're going to have 4.5, 5.3, 5.3, 5F, 4.3, 4F, 4.4, 4.5. All right, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's hope I got all this right. And then after that, I need the files pointer, which also can just make garbage. 1, 2, 3, 4, 5, 6, 7, 8. All right, so then we need to log out. So we should have a prompt again, and we'll say log out. And then we'll log in again. So it's going to ask me again for the length of the username. So I'll say 3. Should ask me for the actual username. Let's send it 3 A's. So hopefully what will happen is when we do this next login, the structure will get this freed username. This will all be filled in. We'll be able to print the flag, and life will be good in the world. So what's the name of that command? Print-flag. Print-flag. So when we log in the second time, if this is the structure, those codes should match. It should print the flag. And we'll sit around and wait for it. Okay, Python messy-malloc.py. Oh, I made a mistake. Oh, yeah, I have a 3 there. That 3 needs to be in quotation marks. And here we go. Got to clear your malloc memory. Yeah, so the key there was I was able to get it to reuse my string as a structure. Those fields were filled in with data from my username, and then enabled me to get it to print the flag for me.